If you found it on another planet, you would call it a machine. It has 8 legs, but no muscles to extend them. It moves using hydraulic pressure, pumping blood into its limbs like a construction crane. It has 8 eyes, positioned to create a 360-degree surveillance grid that detects motion faster than the human brain can process. It doesn't buy materials to build its home. It prints them. It manufactures a substance inside its own body that is 5 times stronger than steel and more elastic than rubber. And it doesn't eat its prey. It drinks them. It turns solid flesh into soup while the victim is still alive. We call them spiders. And we treat them like pests. But they are not pests. They are the most sophisticated engineers in the history of life on Earth. They are 400 million years of evolutionary perfection. And they are everywhere. Nothing about the spider is normal. Here's why. We are about to dismantle the blueprint of nature's perfect assassin. Subscribe now. You'll never look at a corner of your ceiling the same way again. Welcome to the web. To understand why a spider is not normal, you have to look at how it moves. Look at your own arm. You have a bicep to pull it up and a tricep to push it down. Muscles work in pairs. That is how vertebrates move. Spiders ignored this rule. A spider has muscles to curl its legs inward, but it has no muscles to push them outward. Instead, it uses blood pressure. The spider's body is a pressurized tank. When it wants to jump or run or strike, it rapidly spikes its internal blood pressure, firing fluid into its legs. They snap outward with the force of a hydraulic piston. This is why spiders move in that jerky, robotic way that triggers our phobias. They aren't walking like animals. They are operating like machinery. And this is why, when a spider dies, its legs curl up into a tight ball. The hydraulic pressure is gone. The system has depressurized. It is a biological robot. But a robot needs a weapon. And the spider has evolved one of the most terrifying chemical weapon systems on the planet: venom. We think of a spider bite as a sting, a sharp pain. But the purpose of venom isn't just to kill. It is to cook. Spiders cannot chew. They have no teeth to grind meat. Their mouths are effectively straws. So, they have to turn their prey into a liquid. When a spider bites a fly, it injects a cocktail of neurotoxins to paralyze the victim. But mixed in with the poison are digestive enzymes. These enzymes work fast. They break down cell walls. They dissolve muscle tissue. They liquefy internal organs. Inside the hard shell of the fly, the body is turning into a nutrient-rich slurry. The fly becomes its own soup bowl. The spider waits. It lets the chemistry do the work, and then it simply drinks the contents, leaving behind a hollow, perfectly preserved husk. It is a horrific way to die. To be dissolved from the inside out. But the spider isn't just a chemist. It is an architect. Let's talk about silk. We are so used to seeing webs that we forget what they actually are. This is a protein that starts as a liquid gel inside the spider's body. As it is pulled out through the spinnerets, the physical stress aligns the molecules into a solid fiber. It is an instant phase change, liquid to solid, in a fraction of a second. And the material itself is baffling. It is tougher than Kevlar. But the web isn't just strong. It is smart. The orb weaver spider builds a web that is electrically conductive. When a flying insect like a bee or a fly flaps its wings, it generates a static electric charge. The web actually flexes towards the prey. It reaches out to grab the victim using static attraction. The web is not a passive trap. It is an active sensor. Spiders can tune their webs like a guitar string. By tightening certain strands, they can feel specific vibrations. They can tell the difference between the wind, a trapped leaf, and the struggle of a moth. They are sitting in the center of a giant external nervous system. But not all spiders sit and wait. Some of them prefer to hunt, and this is where the story gets truly dark. Because some spiders have evolved strategies that seem almost human. Meet the bolus spider. It doesn't build a web, it builds a fishing line. It spins a single thread of silk with a sticky glob of glue on the end. It hangs from a leaf, holding the line with one leg, and then it hacks the chemical communication of moths. The bolus spider releases a pheromone that perfectly mimics the scent of a female moth. It is a biological catfish. The male moth smells love. He flies in, looking for a mate. He follows the scent trail right to the spider. As the moth gets close, the spider swings the sticky line like a cowboy with a lasso. Whack! It strikes the moth in midair, reeling it in. It is precision hunting, using chemical deception and tool use. But even the bolus spider is simple compared to the Portia spider. Portia is a jumping spider, but it doesn't hunt flies. It hunts other spiders. It is the Hannibal Lecter of the arachnid world. Portia is a genius. It has the cognitive ability of a mammal packed into a brain the size of a poppy seed. When Portia finds a web-building spider, it doesn't just attack, it plans. If the target is too big, Portia will step onto the edge of the web and pluck the strings. It mimics the vibration of a trapped fly. The target spider rushes out, thinking it has found a meal. Instead, it finds a predator. If that doesn't work, Portia will mimic the rhythm of the wind, masking its footsteps to sneak up on the victim. Scientists have watched Portia stare at a target for hours, planning a route. It will actually climb away from the prey, go up a tree, and rappel down a silk line to drop on the victim from above. It understands 3D space. It understands object permanence. It understands strategy. It is a thinking machine. But for all their genius, spiders have one fatal flaw. One blind spot where their survival instinct fails. Reproduction. For the male spider, finding a mate is a suicide mission. In many species, the female is a giant compared to the male. She is a fortress, and she is hungry. The male black widow knows the risk. He approaches the female's web and begins a specific tap dance. He vibrates the web in a coded rhythm that says, "I am a male, not a meal." If he gets the rhythm wrong, he is eaten instantly. If he gets the rhythm right, he gets to mate. But even then, his chances are slim. During the act, he has to be careful. If he lingers too long, the female's predatory instinct kicks back in. In some species, like the redback spider, the male doesn't even try to escape. He essentially somersaults into the female's mouth while they are mating. He feeds himself to her. Why? Because a well-fed female is less likely to mate with another male. By sacrificing his body, he provides the nutrients she needs to grow his eggs. He is the ultimate provider. He gives everything, his sperm and his life. But surely there is safety in numbers? Surely spiders work together? Usually, no. Spiders are cannibals. They hate company. But there is an exception. An anomaly that breaks every rule of spider biology. The social spiders. In the deep jungles of South America, there are colonies of spiders, Anelocymus eximius, that live in the thousands. They build massive communal webs that can cover entire trees. They are sheets of silk stretching for 20 feet, occupied by thousands of spiders living in harmony. They hunt like a pack of wolves. When a large insect, a grasshopper, or even a small bird hits the web, hundreds of spiders swarm it at once. They overwhelm it with sheer numbers. They share the food. They care for each other's young. It is a hive mind. A arachnid city. If you touch the web, a ripple of movement spreads through the colony. Thousands of legs moving in unison. It is a nightmare scenario for any arachnophobe. But for the spiders, It is the only way to catch prey bigger than themselves. So, what is a spider? A spider is a precision instrument. It is a creature that mastered engineering before humans stood upright. It mastered chemical warfare before we invented gunpowder. It can survive in the desert. It can survive underwater. Look at the diving bell spider, which builds its own oxygen tank to live beneath the surface. It has conquered every corner of the globe. Scientists estimate that you are never more than 3 feet away from a spider. Even now, they are in the walls. They are under the floorboards. They are watching from the shadows with 8 unblinking eyes. But they aren't watching you with malice. They are watching you with efficiency. They aren't monsters. They are just better than us. Better at waiting. Better at building. Better at killing. So the next time you brush a cobweb out of your way, stop. Look closely at the architect sitting in the center, and be grateful it is small. Because if spiders were the size of cats, we wouldn't be the dominant species on this planet. We would be the soup. If you thought spiders were efficient killers, wait until you hear about the squids of the ocean and how bizarre they get the deeper you go. That's next time. For more investigations into the dark, criminal, and bizarre side of nature, subscribe to The Dark Biologist. You will never look at the world the same way again.